All right, on to 5.3, which is exponents, polynomials, and functions, and we're going to be looking at doing operations with functions again. So we're going to be looking at function notation. How do we write that we want to use or do different operations with functions, some of that notation that we want to deal with. So for this first part, we're going to be looking at add, subtract, primarily, so addition and subtraction, and with function notation and evaluating those functions at different values. So let's make sure everybody's okay with what function notation is all about. So if you see something like f of x equals f of x, f is the name of the function. So f is the name of what that function is called. So that's just the name. And then the x is the variable that we use to write the rule. So they call that the independent variable or your domain variable. So it's just the variable that they're using to write the rule. It does not mean multiplication. So this is super important. So you read this as not multiplication. So it's f of x is like basically a fancy way of saying y, that output. So when we put the x value in, we get this f of x or y value out. So even think of it like an ordered pair, you know how you normally have x comma y, well this is x comma f of x. So we put that x value into this function, this rule, and we get that as our output. So it's not multiplication, so just be careful as you read that. So if I'm asking you to do, for example, f of -4, then what does that mean? So you read f of -4, it's not f times -4, it's f of -4, of meaning x value that I want you to use is -4, and you're going to substitute that in for x into your original function, and then you just do order of operations to solve. So if I want to do f of -4, I'm going to put in opposite of -4 squared plus 5 times -4, and then minus 11. Notice something I did when I substituted. I put parentheses. That's really important to help you keep track of signs. The biggest issues people have with these is just order of operations and getting wrong values. So we just want to be really careful when we do that. So f of -4 would be whatever this value is when we figure it out. So -4 squared, order of operations here, would be 16, but then we take the opposite. So -16, 5 times -4 would be -20, and then minus 11. So when I put all of that together, go ahead and take a moment. Feel free to use a calculator if you need to. Pause. That would be negative what altogether? Looks like 47. All right, so what does that mean? That means this coordinates to the ordered pair. -4 was my input or my domain. -47 was my output. It represents an ordered pair on the graph. So we can use function notation as a way to describe operations then that we want to do. So we're going to be using this idea of function notation. So let's just do an example of where would someone see an example like this in a real life situation. So I'm going to take a look at a polynomial function that is looking at how many bills people are paying. So paying online. Now I'm guessing that this is almost 100% if we look at how things have changed over the past few years. But this data was real data from 2000 to 2006. And they're looking at how many people paid at least one bill online during those years. Can definitely contrast that to what we're doing now. And take a look, it's a trinomial, so 1, 2, 3 terms. And it's in descending order, so we have our degree 2. So it's a quadratic trinomial. And this is a polynomial for paying, so paying at least one bill per month. Now the way that they set this up is x equals 0 is corresponding to the year 2000. So when you think about substituting your values in, if you substitute in 0 into this function, that represents the year 2000. So what would 1 represent then? Well, 1 year past 2000. So that would be 2001 and so on. So that's how they did it, just to make it a little bit easier to work with. And then the output, the y, this p of x, I'll call it now, is the number in millions. So the answer that you get for it is how many millions of households pay at least one bill online. So we're going to use this to make a prediction. So once we have a model in a real life situation, we can use it to help predict. We're going to approximate the number of households that paid at least one bill online in 2006. Okay, so if 2001 was 1, what would represent 2006? What x value? Well, that would have to be a 6. So how would we figure out how many households paid at least one bill online in 2006 each month? Well, we're going to evaluate this function at 6. So we're going to do p of 6. Remember, that's our input value. The x is going to be 6 for 2006. So that means I'm going to be doing 0.808 times 6 squared plus 2.625 times 6, just substituting 6 in for every x, and then plus 0.502. So I just need you to grab your calculator. We're going to type that in. This is definitely not something you'd want to do the arithmetic by hand. We're going to use our calculator, and we'll see if we can get this. All right, so just be careful when you enter it in there. I would just do it all in one step, and we can see what we get. So it's 45.34. So the output 45.34. And remember what that's in? What are our units in here? It said that the P was in millions. So this would represent 45.34 millions of households. So million of households, millions, I guess, paid at least one bill online back in 2006 each month. So that's how many households would have been then. Now we can project and probably guess that that has probably grown astronomically because of how we do everything online now, including school sometimes. So when we look at how we use functions, they can use to model real life situations. So function notation is a way to express that. Okay, so we can do operations like that as well. So we're going to talk about adding and subtracting functions using function language instead, this function notation. So I want you to take a look. They're going to give you an operation that they want you to do. So I want you to read this and see if we can interpret what that means. So f plus g of x is how you would say this. So f plus g of, really important, x. This does not mean we're multiplying these two things together. It means we're going to take the rule for f and the rule plus g, and we're going to add them together. So this f plus g, that's the name of the function that they want you to do again, and x is the independent input variable that you use to write that rule. So it's the input variable, like the domain variable. So when you see an operation symbol between function names like that, it's telling you what they want you to do. So what does that mean? It means, hey, take the rule for f of x, whatever that is, and you're going to add it to the rule for g of x. That's just a real fancy way of them saying, I want you to add these together. So that function notation means addition. All right, so if I'm going to do f plus g of x, remember that is not multiplication. That means I'm going to take the rule for f, which is 3x squared plus 8x minus 6, and I'm going to add that to the rule for g of x, right, which is this. So the rule for g of x is negative 4x squared plus 4x minus 8. So I'm just really doing like terms. That's all it is. So just be aware when you see that operation symbol between two function names, just do that operation with the true rules. All right, so now we're back to like terms again. So I want to figure out what the sum of these two functions would be. Let's look for like terms. All right, so I see a 3x squared. Do you have any other x squared terms? Looks like we have one over there. All right, see if we have anything else that's in common. Do we have any other x's? So it looks like we have some x's here. And then the last one looks like I have just a constant and I have just a constant. And we again are adding together. Okay, so go ahead, pause the video, see if you can come up with what do you think this polynomial should be when you add f, the rule for f, to the rule for g. All right, so 3 plus negative 4 would be negative 1x squared. You don't need to have the 1. You could just say negative x squared, and that's the same thing. How about the x's here? We have an 8 plus 4, so plus 12x. So this is kind of an either or here. And then minus 6 minus 8 more would be minus 14. So the sum of the two, so f plus g of x is equal to this negative x squared plus 12x minus 14. It's just putting like terms together. So if you see f plus g, add the rules. Okay, well, guess what? If you see f minus g, again, this is the name of the function, and then this is the variable that you're using to express it. I know that's a lot of things going on there. That is not multiplication. That means subtraction. So whatever symbol is in between the two function names, that's what they want you to do with those two functions. They want you to subtract the rules. So we're going to take the rule for f, so this whole trinomial, and we're going to be subtracting the rule for g this time. So f minus g of x, that's what they're talking about when they show that. So let's see what that would look like. So I'm going to take my rule for f, so 3x squared plus 8x minus 6, and I'm going to subtract my rule for g, And notice I'm using parentheses. It's really important when I think about subtraction, especially to use parentheses. I know I did for addition too. It's not as big of a deal there because adding, you can do things in whatever order you want, but subtracting changes the sign. So we have to be really careful here. So remember how that distributes through to everything in that second set of parentheses. So the entire rule for g of x needs to get subtracted. And you know what people are going to do. They're going to subtract that first term, but then they kind of forget about the other two. So use parentheses. It really does help. Okay, so here's what I'd like you to do first. Pause the video. Can you distribute that negative through and see what you get for that second trinomial? What terms would you have? So go ahead and pause and do that. So minus a negative, that would be plus 4x squared, minus 4x, and then minus a negative 8 would be plus positive 8. So just being careful, I'm going to recopy that first polynomial, and now we're going to put some like terms together. All right, so can you take a moment? Please go ahead and put together your like terms that you have for these polynomials now. All right, so I have a 3x squared and a 4x squared. I have an 8x and a minus 4x, and it looks like I have a minus 6 and a plus 8. So see how I'm using different symbols? I'm color coding because I can, but that really does help. All right, so we got a 3 plus a 4, so 7x squared. And then we have an 8x minus 4x, so a plus 4x. 8 positives, 4 negatives. And then we have 6 negatives and 8 positives, so plus 2. Nice pretty polynomial there. All right, so that's f minus g of x. So I can actually subtract the two, and I can get those values. And it's just a matter of making sure you're careful with those signs. That's really the issue that people run into. All right, well, we can evaluate these sums and differences at particular, oopsie daisy, locations as well. So we can actually do the adding and subtracting at a particular value, and that's what we're going to take a look at for this last one. So we're going to start with two different functions than what we've had in the last one. So I'll try to keep color coding here. So my function f is a 1-2 term thing, so what we call that, that would be a binomial, and then our g of x is just a monomial. Monomial meaning one, just a single term. All right, so they're going to ask you to do the same things that you were just doing before, but I'm curious if you can tell the difference in these questions. Instead of f plus g of x, it says f plus g of 3 for the first one and then negative 2 for the second one. What does that mean? Well, it means they just want you to evaluate each of those functions at 3 and then add. So this still means f of 3 plus, because that's the operation symbol in between, g of 3. So I'm literally going to do that addition. I'm going to take the value of the function f plus the value of the function g. It is no different than when we started with f plus g of x. Go back up and look at this original one here. F plus g of x. X could be anything. I'm just saying now it's 3. It means I'm doing the first function evaluated there and the second function. So it's really the same exact thing. So we're going to be plugging 3 into the function f. So I'm going to do my arithmetic here. So 18 times 3 squared minus 24 times 3. I'm going to figure out that answer. And then I'm going to add it to, I'm going to plug in 3 into g. That one's a little bit easier to do. So 3 times 3. That I can figure out. And that will be what f plus g of 3 is equal to. So I just need to evaluate each of those functions at 3. So go ahead and pause the video. Can you do some arithmetic for me? Could you do f of 3 and then g of 3 so we can figure out what those values are? All right, so for f of 3, 18 times 3 squared minus 24 times 3, I got 90. So hopefully that's what you guys were coming up with as well. So that's 90. And then plus, because this was addition, right? Adding, so plus. And then g of 3, plugging in 3 into g. 3 times 3 is just 9. So 90 plus 9 gives us a grand total of 99. So we have f plus g of 3. So I'm doing the same thing. It's just you end up with a numerical answer, which for a lot of people is an easier way to go sometimes. So it sometimes makes life a little bit easier. All right, so what would f plus g of negative 2 mean then? Well, you're going to do the exact same thing, but evaluated now at negative 2. Negative 2 is your x values. That would be f of negative 2, and then plus g of negative 2. So whatever operation is in between your function names, that's what you're doing, and then you're just evaluating it at that number. So now we just need to do that same calculation, but with a negative 2. So we're going to plug in negative 2 everywhere we have an x. So 18 times negative 2 squared minus 24 times negative 2. So that'll be f of negative 2. And then plus, because we're adding, so plus. And then we're going to do g of negative 2. So I'm going to plug in negative 2 in for g. So 3 times negative 2 will be g of negative 2. So let's go ahead and do that blue f of negative 2 here first. All right, so I plugged in negative 2. It looks like I got 120. Double check and see if that's the same calculation as what you came up with. So 120, and then we are adding that to 3 times negative 2 would be negative 6. So 120 plus negative 6. So that would be down to 114. So 114 would be your final answer for that. So when you're doing a function notation evaluated at a particular number, we're just plugging that number in. All right, so last one. Now we're going to do a subtraction. So remember what it means to subtract two function names. So I'm looking at that minus sign right there. That means I take the first function evaluated at that number. So we're going to evaluate at 1. And then minus, so we're subtracting g of 1. Okay, so we need to do those evaluations again. So I'm going to be plugging in 1 into the function f. So that would be 18 times 1 squared minus 24 times 1. Get my answer for f of 1, and then I'm going to subtract off, plugging in 1 for g, so 3 times 1. So that should be pretty easy on that end. So this would be f minus g of 1. Okay, so let's go ahead and do that arithmetic there. Thankfully, when we do 1, it's not as bad. 1 squared is just 1. So that's 18. 24 times 1 is 24. So 18 minus 24 looks like it puts us at negative 6. And then we're going to subtract off 3 times 1, 3 more. So that looks like it's putting us at what? Negative 9. So f minus g of 1. So the whole idea of function notation is it's a way that we can do adding and subtracting where we're just saying the names of the functions, and then we can still do the rule. And we can do that whether we are doing it at a particular number like these, or we can do it where we just did it with the variable x, and that's fine too. It's just function notation is another way that we can talk about adding and subtracting functions.